Thank you everyone for the very overwhelming welcome. I'm quite embarrassed about the CV that was just read out, and it makes me very tired to think about those things that I've done. It's a great honour to be here at the RICS School and to have the opportunity to address you. The RICS School, sorry. I was at the RMIT graduation in Singapore on the way here, and the Royal Institute of Chartered Surveyors gives an award to our best student, and I was very careful to read that out at the graduation and make sure that everyone knew it was the Royal Institution of Chartered Surveyors. So I shouldn't have said RICS, I'm sorry about that. What I wanted to do today is talk a little bit about, let you know a little bit about RMIT, something about the school that I lead at RMIT, maybe a little bit of background on me, because I was a very reluctant academic, and I think sometimes for students in your situation it's interesting to think about someone's career and how they ended up in the situation they're in. Then I wanted to talk to you a little bit about a historical example, and not historical in Indian terms, but probably historical in Western terms, of what I consider an example of efficiency and best practice in construction management and delivery. And the thinking there is that what is new is not always better, and we sometimes forget what we've forgotten as a profession. Then I want to talk a little bit about construction innovation, and then finish off with some ideas of some of the research we're doing in the school at RMIT. Hopefully it'll be interesting. If it's not interesting, wave your hands and I'll move on to the next topic. So just to give you a bit of background on RMIT, I don't know how well known RMIT is here in India, but our university started in 1887 in Melbourne as a working man's college. It was founded by a benefactor who dedicated the university to giving working people an opportunity to receive an education. And that's been important in our ethos as a university ever since that time. The university now is the largest multi-level university in Australia. We have 82,000 students, something that I was pleased to talk to your Vice Chancellor about yesterday. She was somewhat shocked at the size of our university, I think. And we've also been very experienced in delivering international university education, with some 30,000 international students as part of that 82,000 students. Just to give you an idea of the things we think about that are important in our university, I thought it was worth sharing our strategic plan value statement with you. So we are trying to be creative, connected to industry, obviously fair. We're passionate about what we do, especially in the School of Property Construction and Project Management, and we're committed to making a difference to society and to the people that attend our university. And I use those things to actually help me understand what we're doing at the university, and I try to talk to my staff and students about what's so important about what we do in the built environment professions. I thought you'd like this is a very stylised picture of where my office is, and it's the somewhat famous Building 8 that everyone in RMIT in Melbourne knows. It's a very quirky building, and RMIT is quite famous in Melbourne for the I guess, quality architecture that we bring to the city and the vibrancy that we bring to the city. The university is right in the middle of Melbourne CBD, and therefore has a real identity in the city. Just some other photos of some of the buildings that are in that city campus. There's a mixture of new and historical buildings, but not historical from Indian perspective, I know. And some idea of, we also have a lot of real estate in these small 1860 terrace houses in the northern part of our campus. And the new, this is called the Swanson Academic Building. It's quite an icon in Melbourne. Won most of the building awards in Australia in 2014. And when the person who introduced me said that I chaired the university's Learning Space Advisory Group, this is one of our new buildings with new learning spaces. If you're interested in those types of things and sort of architectural innovation in learning spaces, this building is worth having a look at, and there's a lot of information about us on our website. In fact, the last time I gave a lecture something like this was in the main lecture theatre in this building to my final year students. So I'm very interested in the building. The facade has some cleaning issues that I'm sure those of you who are interested in facilities management would like to think about, which we had a lot of arguments with the architects about that, but they got their way. Anyway, to move on to talk a little bit about our school. At the current time we have around, I think I've probably underestimated the number of staff. We have around 35 full-time staff in the School of Property Construction and Project Management. Some part-time academic staff, 12 administrative staff, and we have around 40 adjunct teachers in the program that come from industry to teach our students. We have around 1,300 students in Australia in our undergraduate program and 250 postgraduate students. And we also have a program in Singapore which has around 300 students. And that program's existed in Singapore since 1996, so we have a history of around 1,400 graduates in Singapore. And we started a program in Hong Kong in 2013 that has around 100 students now. So I was saying to Professor Swanson, we've taken 10 years at RMIT since I became the Foundation Head of School of Property Construction and Project Management to get to the size that your school has got to in 2 years. So I congratulate your school management on that. I'm quite envious. So in terms of the, how I came to teaching in construction, you heard in my biography that I'm actually a civil engineer by first profession. I thought that when I started in industry, I'm somewhat like the RMIT ideal in that I really started in the construction industry as a plumbing apprentice, and my father is a plumber. So from somewhat humble academic beginnings, I was first in family to go to university, and so I think it's quite interesting to see that you could have that path in life, and I'm quite surprised, and my father still says he's quite surprised when I talk to him that that's what's happened to me. But through the opportunities that were afforded to me, I managed to do a civil engineering degree and work as a civil engineer in a government agency for several years. And then my professor from University of New South Wales suggested I go and do some graduate study. He wanted me to go to the university that I went to, but I was given an opportunity to go to Princeton University on a scholarship to do my master's degree, and that was a great opportunity that I think I'm still living the benefits from. My mentor there, David Billington, is a very interesting guy, a structural engineer who's talked about the art of building and what's important in building, and that has, I guess, informed my future career. So what I've managed to do subsequently is link, I guess, my construction experience in the field with my engineering experience to then bring that into an academic setting. And you'll see when I talk about the research and the way our school's set up, that's really been something that we're very passionate about, understanding the building process, being involved in that building process. And our research and my research and practice has always been about that, somewhat to the frustration of the people who originally taught me structural engineering. They think I might have wasted my academic career, but I don't feel that. So I thought it was good to give some historical perspective, not only to the construction research, but also my research, and this is really for Professor Sahoni. I wanted to talk a little bit about construction process modelling, which is, I think, where we both started in our at least our post-PhD research careers, and modelling how the thing that drove me from my structural engineering background was this idea that we need some underlying models for how we actually construct. What we tend to do in construction is it tends to be an experientially based profession where people work on systems that they've been taught by someone else without necessarily understanding why they do the things they do. And so that's something that drove me very much in my early career, is try to make models to help us understand construction much better. And things that I worked on were abstract process models. This is a Petri net, which it's a shame Professor Swaney's left the room, because this slide was just for him, because he also did work in Petri nets. And the thing about this was it's a very interesting abstract modelling, mathematical modelling thing where you can understand the dynamics of construction processes and how those processes interact. And while you think this might not be relevant, it's going to be something that's relevant to the historical example that I'm going to talk about. And then the other thing that I did early in my career that really led to me going back to the US in the late 90s, I did a lot of work in what was, I guess, the early precursors to BIM, around 4D modelling and simulation. And I wanted to show you how this was work that we did in the early to mid-1990s at Uni of New South Wales that was, at its time, very new and very exciting, where we managed to link schedules with the 3D CAD diagram. And this is some modelling that we did on the Commonwealth Games Centre at Kuala Lumpur in Malaysia, if you want to get some perspective. But I thought it's quite interesting to look at. This was, at that time, extremely difficult to do from a modelling perspective so that you could see what was planned to happen in the schedule. Now this is a very simple thing for all of you to do with the software that we have. So in a period of 12 to 13 years, that has become something that's quite routine and easy to do, but then it required a lot of programming and it was very difficult to do, so that we could step through the schedule and get a view of what the building was going to be like. It's a great disappointment to me that it's taken 20 years to get from what we thought you could do in the mid to early 90s to where we are now with BIM. The implementation has been much slower than I would have hoped. And somehow I don't work as much in BIM now because of that frustration, I think, of how slow it's been. It's really been not the technology that's been slow, it's been the industry take-up of the technology that's been slow. So the other work that I've done is really in housing research, and that's work that I did at Virginia Tech when I moved there in 1998 with the US federal government, and that's where Professor Savoni and I met, working on affordable housing and trying to increase, I guess, the speed and the amount of technology that was used in housing development. We worked together on the Partnership for Advancing Technology in Housing program, which was a large US government funded to the order of $5 million US dollars over a 5-year period to try and improve the efficiency of residential builders. And I think it did make a big effect on those builders, but then we had the financial crisis that I guess undid some of those advantages, where they built too many houses and then couldn't sell them. There's certainly a cautionary tale for us all in the fact of overbuilding for a particular market. So we also need to be, if we're developers and builders in the industry, we need to be thinking about developing appropriately for the market so there can be take-up and it does work for you. So I'll just take a pause and a little sip of water there while, before I move into the second part of my talk. What I want to do now is talk to you a little bit about something that I think is a humbling experience for us all, and it's something we need to think about, is that when I went to Virginia, I met an architecture professor who talked to me a lot about the Empire State Building, which is for Americans was an architectural icon for their construction industry. And what I'd like to do is just give you some background to that so you can place it in context. The Empire State Building is 86 stories tall. As a building, it has a massive floor plate. It takes up a whole city block in New York. The interesting thing for me about this building is it was, for most of the 20th century, it was the largest building in the world, and it was built in the late 1920s, early 1930s. The interesting thing I try to tell my students about this is that at that time, so that's now what, 80 plus years ago, they were able to build this structure in 20 months from start to finish. So from the time of demolishing the structure that was there to actually finishing the structure is 20 months, which is something that the best Australian contractors in Australia still could not do. So we've done benchmarking studies against this particular building, and it takes much longer than that. So what I'd like to do is sort of show you a presentation of the Empire State Building as an integrated construction system. Because I think what happened in that project is they managed to integrate the design, the construction and the off-site manufacturing in a way that we're striving to undertake now. And yet they did it without any of the technology that we have, the IT technology. And so what I want you to think about from that is what's important, the management. There's two parts, the management and the technology. And what's interesting about this building is they did that management without any of the technology that we currently have. Critical path method wasn't developed, there was no computers, none of those things. But I think they still managed to achieve what is a phenomenal construction achievement. So the things that are highlights of this building are the team design, the fast tracking, so the integration of efforts between the developer, the designer and the builder. A production focus, they thought about production of the structure and the building when they were doing the design. So if you want to talk about a concurrent engineering approach, I'm going to try and show you some examples of this. The other thing was that the builder's management and organisation of the work and the transportation of materials was, for the time, incredibly innovative, but still looks innovative to us today. At least for me, as someone who's an expert in high-rise construction. So to talk first about the team design. So this building was the highest building by quite a number of stories, around 20 stories higher than the next highest building that existed in the world at that time. So the ideas are that the design required skills beyond the training of the structural engineers and architects that were involved, and that they needed to get not only those people involved but also the constructors involved in figuring out how to undertake this quite incredible technical feat. So just to give you an idea, I've got some quotes here that are from the original documents of the time. So the other thing that's really interesting about this building is the architects, Robert Shreve, and the builders, Starrett Brothers and Ecken, actually documented their work in the professional journals at the time. So you can go to the 1930 Architectural Journal and actually look at their original documentation of the project, which is really interesting, and it's something that most of us as constructors and construction professionals don't do now. But in that article you can see there's information that talks about the architects talking. It says these problems, talking about the construction and design problems, must be dealt with through authority greater than the architect possesses, and would avoid a duplication of effort and a loss of time, too expensive to be tolerated in an operation requiring large capital investment. If you look at that quote, it's exactly the same issue we face in major developments now, the cost, the time, and how we overcome those technical difficulties. And then there's a quote from the builder, Starrett Brothers and Ecken, from Paul Starrett, saying, "I doubt there was ever a more harmonious combination than that existed between the owners, architects and builder. We were in constant consultation with both of the others. All the details in the building were gone over in advance and decided upon before incorporation in the plans." So the construction system was decided upon before it was incorporated in the plans. And I should... so I hope you can see this, but I'll make available the presentation for you. But on this diagram here that I'm showing is an example of that integration. It shows this shows that all of the steel that needed to be fabricated for the building, all on one drawing, and the dates with which that steel needed to be fabricated, when the mill orders had to be placed, when the shop drawings needed to be done, and when they needed to be delivered. So this building, all the steel was fabricated off-site in New Jersey and floated across the Hudson to Manhattan Island. And this is from the journal Architectural Forum in 1930, this particular thing. So that's the integration of information, all on one drawing. We couldn't imagine that for a 100-storey building today, that we could put all of the fabrication information on one drawing. We'd have a very big CAD file, right, that we'd have to use. So I'd like you to think about that in terms of simplicity and how they've integrated their operation. The other thing that's interesting is the way they actually scheduled the project. So they used a linear schedule to work out the manufacture and erection and delivery of the Empire State Building. As I said, all fabricated off-site on steel mills, floated on barges across the river, and then erected without the use of a tower crane on site. This diagram that I'm showing here, again a little bit small on the projection, is a linear schedule for the project. So on this one drawing again, it shows you on the vertical axis is every floor of the building, on the horizontal axis is time. So it shows you a rate matched schedule for the erection of all, for fabrication, erection and delivery of all parts of the building. And this is the way they used to control the schedule on the project. No critical path method, just this linear schedule. So I think they're two very interesting things to think about that they were able to control. And the other thing you can do is you can do an as-built schedule on this linear schedule. So you can see if you're matching the rates that you need to match to actually balance the production across the project. The other things that they did that were very interesting is they used a very complicated but simple method of horizontal transportation of materials on the site. So on every level of the site they had a small mining railway that allowed them to move things around the site, and I've got some pictures of that allowed them on every floor to move things around the site, and also they used interior lifting in the building to do the vertical transportation. So these little mining trolleys allowed them to shift things horizontally but also to shift things vertically. Steel building with tile infill, so still kind of a different construction system to what we might use now, and then a stone facade on the building, and you can see the moving the stones around and the turntables that they were using there. I hope this is clear on them. It's clear on the one I'm looking at, but hopefully it's clear on the one. So these are original photographs taken and from the project manager's diary, which was found in the basement of one of the New York buildings where Starrett Brothers were based at that time. So original documentation. Again, the railway showing you how they're moving on this very large site. If you imagine a full city block and you have to move all of these things horizontally, horizontal movement of materials on high-rise construction sites is still a problem that we haven't solved now. So you can see there's three things that they did here that were very different and we could learn from, or we've forgotten. So the reason we may have forgotten that, this building completed in 1930, some months ahead of schedule, but then the US and the rest of the world went into the major depression, and then subsequent to the depression, Second World War, no more high-rise buildings built until the late 1950s. So generally the people that were involved in this project were no longer active in the industry after this project. It's the last big project that was done before the depression. So we might have forgotten some of these things, and we also didn't look back at the professional journals of the day in terms of informing our practice now. And that's something I'd like you, if nothing else, to take away from this lecture. And before you say things that were very different in 1930 to now, I think some of the things that were prevalent in the US at that time are things that are true here in India. I think there was a lot of labour available at that time in the US, and so at the peak of this site they had over 3,000 people working on the site. Something we probably wouldn't do, at least in Australia now, but very common. If you've got a lot of labour, you could do this type of thing at that time. But there was quite a poor safety record. Around 10 people were killed in the production of this building, which is something that wouldn't be tolerated in Australia in the current environment, and shouldn't be tolerated. And then the management of the process was really focused very much on production management. And in Australia now, what our contractors tend to do is focus on managing subcontractors rather than the productive process. And that's something that they seem to be able to do extremely well here. And that's really a very good understanding of their scheduling system and the production-based process that they used. So a very common concentration on the construction process. So I've got some other things in here that you can look at later, but in the interest of time, I will keep moving. So education was very different, obviously, at that time. And the thing that's changed since 1930 is in all areas of construction, we've grown in specialisation. I'm speaking particularly here from the Australian experience, where every little part of work on site is done by a different subcontractor, which makes it very difficult to integrate the efforts of everyone on site. There's a lot of demarcation in Australia. We're a very unionised workforce, so there's a lot of different small areas that you're only allowed to work in one area and not in the other, which has led to us having a lot lower productivity than happened in the Empire State time. And that level of specialisation has also become a problem in the design community, where you've got lots of different types of design and they don't necessarily work together in a very integrated way. That's true in academia as well. So these are just, I guess, observations that you might think about. I know this is not true at your school in that all of your staff have industry experience and understand the industry, and it's also true in my school, but I think in general across our built environment professions there has been a real narrowing of academic professions and the disciplines, and so that's caused this lack of integration. So there's some things we can think about, and I'd like you to think about what's not possible from the Empire State Building, but there's things that we could learn. And I'd like us to not just look back, but use those learnings in the past to inform what is our future with the new technologies that we're using. So we have a lot of tools now that we can use for integration, but we don't necessarily have the systems in place to help us do that integration. So it's something you as future professionals can work towards. So think about that and think about how we use it. So I wanted to move from that historical example to talk about some of the things we're trying to do at RMIT in terms of innovation. One of the things that I'm particularly passionate about is the idea that we would try to, I guess, improve affordable housing for the growing population of Melbourne. And so we've done lots of work on trying to look at densifying our suburbs, putting more people into housing within our middle ring suburbs that are close to the centre of the city. And it seems to me there's some parallels with India, though you have a lot more housing issues than we have. We still have, Melbourne's a city of around 4 to 4.5 million people, but it's a very spread out city. And so there's lots of issues for people who are new to the city, living on the fringes and being unable to get to the resources of the city. I've got an acknowledgement in there of my co-workers, because obviously I didn't do all this work myself. I've got some very good people working with me. But what I was saying is that our construction industry today is capable, we're capable of excellent quality and good design, but we don't necessarily have speed and predictability. Because of the things that we could learn from the Empire State Building, we have fragmentation. We have these numbers of large numbers of subcontractors, and I don't know, hearing from some of your staff yesterday, I know you've got some expertise in lean construction, so I'm sure you're aware of the parade of trades going. Have they done that? Okay, where we've got, having so many fragmented trades, it's almost inescapable by systems theory that you will get a lot of delays and a lot of fragmentation in the process. So that explosion of subcontracting that I was talking about has caused, there's some reasons for doing that. It's to move risk from the main contractor to the subcontractor, but it means we lose control of the schedule and we lose control of the quality, leading to a lot of rework. So they're things that we've got problems with in Australia. So what we need to do is try to compress on-site timeframes, so a shorter time between land acquisition and occupancy of the housing. For even a single family house in Melbourne, that's taking us at least a year at the moment, which is completely ridiculous. In the US, in our PATH programs, builders in the US could build a house or sign a contract on a house, and 90 days later people could move into that house. We're a long way away from doing that in Australia. And so we need to do something about that. Because if we can provide predictability and time frame, it allows homeowners, developers, constructors to finance and plan their operation. And we don't have so much risk on holding costs. And we need to develop more robust construction methods. And you'll see where I'm coming from there, that give high quality, dimensional accuracy and opportunities for alteration and repurposing so that housing becomes adaptable to the people, the changes that people in the house undertake over their lifetime. So we've talked a lot about, at RMIT, about process innovations. We've been very focused on off-site construction, and part of that reason for that in the Australian context is our labour cost is incredibly high. So there's a lot of difference, I guess, from India and Australia in that area. Our labour cost is orders of magnitude higher than I imagine it is here, and that's driven us to look at modularisation of both the structure and interiors of buildings and panelisation, the same sort of things that we worked on in the US. And one of the other things I'm interested in is this idea of open building, that we build a framework that's an adaptable permanent structure so that the structure can be modified to suit the use of people over time. It's something that hasn't really got much currency in Australia, but I think it's something we should be thinking about if we're thinking about our urban infrastructure being usable in the future. So ideas of modular or replaceable interiors, extendable solutions, and making sure our utilities aren't entangled so that we can do changes to the building without disrupting the utilities. On my way here from Delhi this morning, I saw a lot of tangled utilities. So I think you have a problem with this in India. Looking down some of those streets in Noida, very tangled electrical utilities, I think. So I'm talking about disentangling that. So if you know where the utilities are in the building, you can do things to modify the building stock that you wouldn't be able to do. So there's ideas about that out there in the literature that we don't necessarily implement. So I just have, in the presentation, there's some examples of some modular examples of work that we've done in Melbourne, but I won't necessarily show you that, except there's one little thing that I'll show you around just a housing solution that I think is quite interesting in an existing neighbourhood, where a modular company delivered these modules by trucks in a very old, prestigious part of Melbourne. So 3 modules delivered to extend an existing house. So to convert a 3-storey, 1-bedroom apartment into a very rich family house. But anyway, I just thought it's interesting to show you how the logistics of this type of modular building can work in an existing neighbourhood. So lifting over existing buildings into what was a very tight site. But the interesting thing about this is the housing is available for use within 1 week of them actually placing the modules. So for a family or a developer who's going to do this, it's a much less compressed time frame in terms of how long it takes to prepare the site, how long it takes to make the housing occupiable by the people. So I think something to think about, and something we've done quite a lot of work on at RMIT to actually mean that we can house more people in existing suburbs. You might not like the look of these houses, but the architect assured me it's a very beautiful house, even if I wasn't completely convinced. And then the other area we've worked on is this idea of modular panelised construction. And these are photos from some work that I did in the US with Pulte Corporation around modular concrete basements. And they were also working to have a house, once start work on site, 1 week later have the house ready for people to move in, which is quite a, I think, inventive way of looking at construction. So the last thing I wanted to talk about in this particular section is this idea of open building, and just give you some thinking about that, about how we might actually go to an adaptable type of residential environment. This is some work we did for the Cement and Concrete Aggregates Association in Australia, where we were looking at precast concrete housing and how you might make it adaptable for use and change of use. So the idea was to set out the house, all the houses they build on a standard grid. Once you've got that grid, you can put parts into the grid and people can manufacture those parts, which again gives some economies of scale of the parts and then gives you an adaptable house. So you can change the number of bedrooms, change the kitchen, change the bathroom, change those things and make the house much more adaptable. And it uses some of the ideas that commercial construction for office building uses. So it's quite normal to change the fit out of a commercial building based on who the tenant is. Similarly, this would work for, the idea of this is to work for housing to change to meet the client's needs. And some ideas around bathroom pod building. This photo's in here to show you a pod, but also mostly to show you the St Paul's Cathedral in the background. So this is my colleague's photograph from when he was working in the UK. And the idea that this idea of utilities being only on one wall of the building, for instance, so that you actually can know where the utilities are and everything else can be changed. So I've tried to give you there some ideas around rethinking medium density construction, thinking about how to make things more predictable and quicker, and thinking about some design ideas around open building. The last thing I wanted to talk about, I had a break for questions there, but I'll keep pressing on, is some of the research that we've been doing at RMIT, and you'll see that in terms of our university strategic plan, all of the research we do is industry need research. So we study in our school, if we can't establish an industry need for the research, we won't actually undertake that research. So we're trying to establish this cycle of connection between industry, our teaching, and our research. So the idea is to think about our research being industry connected, that our research finds its way back into practice, but also we get research ideas from industry practitioners. And this is the way we've built our school. A particular case study around our the type of research we do. So we've got basic research, which has been funded by the Australian Research Council. We have applied research funded by an industry cooperative research centre for construction innovation. And then we have what we call our translational research, which is where we're trying to build our research into the industry practice. And that's been funded by government, industry and contract research. Just to give you an idea of the sort of things we're doing. I thought I'd talk about a couple of projects. One was this is really the first project that we worked on when I came back from America that looked at, we worked on a big infrastructure alliance. It's called the Tullamarine Calder Interchange. It's a big road interchange near Melbourne Airport. The first alliance project. Everyone probably knows what an alliance project is, but it's a government industry alliance where they build a piece of infrastructure. And we designed, or I personally designed the safety system as a research project for the Alliance. The safety system was the way they ran safety on the project, but it also was tied to the way they were reimbursed by the government for performance on the project. So if their safety performance was adequate, there was bonuses to be had. If their safety performance wasn't good, they lost money. One of the things we found that was using this particular, we did a climate index for the people on the site that showed how their safety performance was, but also how they felt about safety. And that was used to inform the workforce and inform the management. And what we found is that the performance actually matched. When people felt good about safety, their performance was much better. When they felt bad about safety, they had a lot more accidents and problems. So a really interesting, for us anyway, maybe not for you, way of thinking about management of safety on the site, which is in Australia is an incredibly important thing. This project had the best safety record of any large infrastructure project in Australia at the time, and won some awards for its safety performance. There was 2 lost time injuries on the whole project, and it was a very large project, a $200 million project running over 5 years. And there's some stuff in there about the way that this changed people on the project. It made them much more focused on performance. It made staff or construction workers on the project much more conscious of safety and alert to where there was safety incidents or potential safety incidents. That led to us having a long-term relationship with that particular contractor. They then partnered with us on a number of research projects because they were very interested in how they could use our research to help their performance. And led to us developing for the construction industry a industry guide to best practice for safer construction. Again, and that's become, I guess, the source document for safety on construction projects in Australia. And I can make that available. It's a publicly available document. It's now being used as the main safety guideline for the very large Port of Melbourne upgrade project in Melbourne and a number of other projects. This work has led to other safety work. We've had about 10 Australian Research Council projects looking at construction safety, and I won't talk too much about those. The last piece of research that I wanted to talk about in this part is some work that we've done where we've done a comparative study between Australian construction safety practice and US safety practice. Because Australian safety performance in construction is much superior to that that's recorded in the US government agency, the National Institute for Occupational Safety and Health, commissioned us and Virginia Tech to undertake a comparative study between different projects in both places. And we've tried to look, this report will become available very soon. It looks at management differences, design differences, and also operational differences, and draws out why those safety records might be very different in those 2 countries. I think the main finding is that a proactive approach to design of the construction operation with a safety imperative in that leads to a much better outcome than not doing that. So the US has a much more of a minimum standard. Australia has a duty of care standard for contractors around their performance. And the last thing I wanted to talk about, I know I keep saying that, is some ideas around developing new tools and using new IT tools. So certainly we've been doing some work on virtual modelling of construction operations, where we're looking at both the ergonomic performance of workers, particularly in the prefabrication and modularisation, and using virtual prototyping to understand the construction process, design the construction process, but also understand the ergonomic strains on the workers involved in using these new systems. And I have links in this presentation to the software that we've used, which is software from Dassault Corporation, the Delmia software. It's really software that's used in manufacturing, but we've been using it for construction operations, as have our colleagues at Hong Kong Polytechnic University. And the other thing that I think is most exciting for people at Virginia Tech and at RMIT is at RMIT we've got a really very expert computer gaming group in the School of Media and Communications. People who design games that I'm sure all of you play in your leisure time. What we talked about with them is trying to develop some games that would help construction workers, young construction workers, learn about construction. So there's a game that we've developed, it's called Trouble Tower. It's an app for the iPad that is downloadable for free that allows people to practice construction safety in their iPad environment. But the interesting thing about that to me is when we looked in the code that the computer gamers have written to actually develop this game, we can actually learn a lot about how the construction process goes together. So they've got code in there that helps us look at what the thinking was behind the construction person undertaking the task. So I think it's got two advantages, this type of research. One, there's an engaging interface for people to learn about construction, to experiment with construction, if they're capable of gaming. I'm terrible at gaming. My son always finds me stuck in a corner of, we play that Halo, I think it's the game. I don't know if anyone plays Halo here. But I always get stuck in the corner and get shot. But for younger people, they are very expert at using this type of thing, and it is very engaging for them to learn about construction. But we can also do some post-analysis of processes and understand what's happening from investigating the code. And I think there'll be opportunities to also capture construction and trade information and skills in this way. So I'm very pleased to be able to address you today. I know I've gone through many different things, and I hope I haven't gone too quickly. I know I have a very Australian accent, but that will help you all understand Australian cricket commentators when you're watching cricket. And I'm happy to give lessons on that, but I'm not happy to talk about the Ashes result today. So please don't bring that up. No questions on cricket whatsoever. Not on India versus Australian cricket or England versus Australian cricket, because that would be too embarrassing for me. But I do hope that there's been some interesting things there. I will make the presentation available. I'll also suggest that if you're interested in the Empire State example, there is a book by Carol Willis that's called Building the Empire State, and I'll send the references to you for that book so you can have a look. I think it's important for us all to think about the tradition of construction as well as the new parts of construction and try and learn from both. So thank you very much for listening.